Okay, for this video, we're going to look at graphs of functions. So if you see a graph, first of all, how can you even tell that it's a function? Well, we do what's called the vertical line test. And so a graph represents a function if any vertical line intersects it at most once. So let's have a look. This is not going to be a function. It fails the vertical line test because, true, there's a vertical line and it only intersects the graph one time, but here's a vertical line and it intersects this graph more than once. So it fails the vertical line test, and so this is not a function. So you only have to find one place, one example, where you have a vertical line that cuts it more than once, and it is not a function. But something like this is a function because I can, and so this arrow means that it's just going to keep going like that forever. Same thing there. So any vertical line that I care to draw only cuts it once, and that's allowed. So a graph represents a function if any vertical line intersects it at most once. So this is a function. This one is not. It fails the vertical line test. So what would we think on, so this is an old textbook, but it has some nice pictures on it. I can just get the focus for a bit. What do we think about that? Is that a function, yes or no? And the answer is no, because we can find a vertical line that would intersect it more than once, so that's not a function. What about this? That looks okay to me. I don't want to draw on the book, but any vertical line that I care to draw would only intersect it once. That one is a function, so that one's okay. This one, I think we can say straight away that's not, because the y-axis itself, you can see where it cuts it more than once. What about that? That looks okay to me. Now this ends here and here, so if I'm out here, I don't hit it at all. And then when I'm in here, I hit it once. Okay, so that's fine. That is a function. Okay, I think we can see this is not a function because any vertical line I draw hits it more than once here. This is a function. And notice when you've got these dots that are filled in, it means those endpoints are included. And if you have dots that are hollow, it means the point is not included. So this is a function. I hit it once, I hit it once, I hit it once, I hit it once, and then when I go through here, I do not hit a point there because that's a empty dot, so there's no point there, but I do hit that one, so I'm only intersecting the graph once. Okay, so this is a function. Now, what about this one? This is not. Don't hit it at all. I hit it once, 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 but then when I get here, ooh, you're intersecting infinitely many points there, so that's not a function. Okay. Well, what else can we say about the graph of a function? Well, if f is a function, and f evaluated at a is equal to b, then the point with coordinates a comma b is on the graph of f. Okay. And we can turn that around. If the point a comma b is on the graph of a function f, then f evaluated at the x coordinate is equal to the y coordinate. And so we should have that in a box. For a function f and a point on the graph of f, f evaluated at the x coordinate is equal to the y coordinate. So we can be given a graph and we can answer certain questions about that graph. So let's look at this. Okay, what do we think about that? First of all, is that the graph of a function? And I take examples from many different books. Okay, let's see if we can zoom in on that. Okay, is that a function? Try and get it to where there's not the glare. Is that a function? Yes, it's a function. It passes the vertical line test. What is f evaluated at -4? So this is a function. Let's call it f. And what is f evaluated at -4? Well, if you're asked that, then how do you find it? Well, remember f evaluated at the x-coordinate is equal to the y-coordinate. So I find the point on here whose x-coordinate is -4. There it is. So f evaluated at the x-coordinate is equal to the y-coordinate. So your answer is 2. Okay. So what is f evaluated at 7? The answer is -4. So f is mapping the x-coordinate into the y-coordinate. Okay. All right, so that's what we need to remember. F evaluated at the x-coordinate is equal to the y-coordinate. So if I've got a picture of a function, is that a function, yes or no? Well, it passes the vertical line test. Doesn't hit it, doesn't hit it. Does not hit there, because there's no point. Hits it once, 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 once. Doesn't hit it at all. Once, 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 not at all. Once, 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 not at all. So that is a function that passes the vertical line test. So let's call this function g. Let's just name it g. So what is g evaluated at 3? Well, look for the point whose x-coordinate is 3. There it is. What's its y-coordinate? So this is the point 3 comma what? 3 comma -2. And so what g is doing is it's mapping the x-coordinate into the y-coordinate. So g evaluated at 3 is equal to -2, and that's your answer. What about g of 5? What's g evaluated at 5 equal to? Well, you have to find the point whose x-coordinate is 5. Here's 5. And is there a point on this graph whose x-coordinate is 5? No, there is not. That point is not there. So this is not defined. Let me actually make some changes to this graph. It's still a function, isn't it? If I do that, it's still a function. Because a vertical line, not hitting, not hitting, not hitting, that point is not there, and hitting it once. So this is a function. So what is g evaluated at -3? Well, I try to find the point on g whose x-coordinate is -3. -3. Now, that point is not there, so I have to find a point. And if there's no point, like it was with 5, it's not defined. But we do have a point whose x-coordinate is -3. It's that point. And what's the y-coordinate? It's -3 comma -2. Okay. And so g evaluated at -3 is equal to -2. So a function evaluated at the x-coordinate is equal to the y-coordinate. So again, g maps the x-coordinate into the y-coordinate. And finally, what if we had a question like this? Okay. Suppose you have a formula. Is the point 1, 4 on the graph of f? Well, how do you answer that? And you don't have a graphing calculator. Well, if 1, 4 is on the graph of f, what do we remember? Then f evaluated at the x-coordinate is supposed to be equal to the y-coordinate. So f evaluated at the x-coordinate, which is 1, must be equal to the y-coordinate, which is 4. So that must be true. But now, what is f evaluated at 1 equal to? We have the formula. How did we do that in a previous video? You rewrite f without the x. And now what do we want to find? We want to find f evaluated at 1, so we put a 1 in here. And so f evaluated at 1 is equal to 3 times 1 plus 2. F evaluated at 1 is equal to 5. That's what it is. But if 1, 4 is on the graph of f, then f evaluated at the x-coordinate must be equal to the y-coordinate, so f of 1 would have to be 4. These two things don't agree. So the answer is no. Is the point 1, 4 on the graph of f? No, it's not. What point is on the graph of f? So this is true, and this is false. So the point, what's the x-coordinate? Number in there. F evaluate the x-coordinate equals a y-coordinate. So the point 1, 5 is on the graph. That's the correct answer.